Hello everyone, today I would like to do some presentation about machine learning, but before we go to start that, let me introduce myself. My name is Helen Kezia Nofitri Siahaan, or you can call me Eza, and I'm from class A with NEM 2023 32035. And here I already open up my PDF. I'm using the PDF, not the Jupyter Notebook, because it was more simple and I want to scroll down and it doesn't have to change at all, so I'm using like this. Okay, for the first row, it was in 15, but it was the first. Okay, I'm so sorry because I'm starting with 15 because I'm doing some re-input code. And here we're using import pandas as PD, import matplotlib.pyplot as PLT, import numpy as NP, and all of the sklearn from model section, import train test split, from pre-processing, import standard scalar, from sklearn matrix, we import accuracy score, classification report, and confusion matrix. From matrix, another matrix, we import Silhouette score, Davis-Baldwin score. Then from tree, we import decision tree classifier. And from Naive-Bayes, we import Gaussian NB. From SVM, we import SVC. From neural network, we import MLP classifier. And the last one is Escalon cluster import, is k-means and agglomerative clustering. And here I'm using the data is Goodreads underscore cleared with the f equal pd.read underscore ccv Goodreads underscore cleared ccve. And here we're using the f to declare that we want to sing all of the data. I'm so sorry for the notification. Okay, we continue. For the first one, we know that we have 100, 1,000 1,000 rows and 4 columns. In here, we have the book title, author name, average rating, and num underscore ratings. And we doing some pre-processing first with the f dropna in place and equal true, with the f num ratings equal the f num ratings as type string, with string dot replace is with comma, and type 0 as type integer with the f rating category equal anywhere. It was to drop out of the data dropner. Then we're doing some feature and target with X is average rating and num ratings, and the Y is rating underscore category. We do splitting data with and scaling with X train. We're using X underscore X train, X task, Y train, Y task, and it was equal to trend task split with X and Y task size is 0.2 with random scale. If I doesn't wrong, it was 42, and the scalar is the scalar with exchange scale is scalar dot fit underscore transfer with exchange, and the extra scalar is scalar transport with it was the x test, and the x scale equal scalar dot fit underscore transfer. It was x. For the classification, in here we're using decision tree for the first one with the code in here. It was with CLV underscore DT. It was for the decision tree classifier. And we're using YPRED underscore DT. It was the CLV dot the CLV underscore DT dot predict. It was the X test scale, and the ACC underscore DT equal accuracy score. It was the Y test and YPRED DT, and the CMDT is equal to confusion matrix. It was the Y test and YPRED DT. We're using breakout decision accuracy as the ACC underscore DT with the print is the classification report. We can new in here the printout. The accuracy is 1.0. It was literally perfect. With the precision is 100. The recall is 100. The F1 score is 100, and the support is 1,620. Sorry, 100 1,638. And for the second one is 100, 100, 100, and 300, 362. But the policy is the macro average. It was 100, and the support is 2000. The macro average is the weighted average is still same. It was 100 at all from the precision recall at F1 score, and the support is same. It was 2000. And we zoom the printout in here with PLT the figure with fixed size is 5,4. Uh, in here, as you can see, it was same like the support in here when the one the one and the zero is same. It was said that for the zero one is using 1638 and the one is 366 62. That was the predict and the actual one. Then we're doing the other classification with NFBS using Gaussian NB in here with the CLP NB dot fit is the exchange code and Y train with Y underscore bread underscore NB is the CLP underscore NB dot predict. It was the X test skill. In the ACC underscore NB is the accuracy score. It was the Y test and Y bread underscore NB. And the last is CM underscore NB. It was equal to confusion underscore matrix, which is the y test and y prime underscore nb. For the accuracy is what it was 0.885, but the precision is for zero is 0.8089 and the recall is 0.99 and the F1 score is 0.93. For the support is still same like the before. It was 1638, and um, for the accuracy one is the precision is a lower. It was 0.88. The recall is 0.42, and the FA score is 0.57. And the accuracy for the micro average a little bit different at the recall and the effort score. For the macro average, we have 0.17 70 and the effort score is 0.75, but the weighted average is has 0.89 and 0.87 at the F1 score. For the support is the same, and as you can see the printout in here, the printout in here because it was a little bit different in here. It will be print out another. The actual is one 1617 and the one is 21. For the actual one with zero predicted is 209 and for the predicted one and actual one it was 153. It was a little bit different because it will be counting from the F1 score and the recall precision. So it's print out like this. Then we're going to talk about the support vector machine or the SVM. For the SVM, sorry. For the SVM, we using CLV dot we using CLV underscore CVM. It was the CVC, which is the CLV underscore SVM dot fit is exchange skilled and the white train, and the white pride SVM is CLV underscore SVM predict. It was the S test skill. The ACC SVM is the accuracy score, which is the white test and the white pride SVM. And the last is CM underscore SVM. It was the confusion matrix. We using white test and widespread SVM. With the SVM accuracy, it will be the ACC SVM. For the accuracy in here is perfect. It was 1.0, but the precision is 100, recall is 100, F1 is F1 score is 100, with support is still same. It was 1,638. And for the one for the one, it was still C. It was have a score 100, 100, and 100 with the precision, recall, and the effort score. And the support is 362. For the macro average and weighted average is still same. It was a perfect number. It was 100, with the support is 2000. For the printout, the penalty figure, it was same like the decision 3. It has a perfect score in here, as you can see. For the actual 0 and predicted 1, it was half the 0, and the actual 1 with predict 0 is 0. And for the number in here, and here is same. For the last is neural network or MLP classifier. We use CLV underscore and which is the MLP classifier with max underscore either equal to 300 with the state 42. Then the CLV underscore n.fit, it was the exchange scale with white train. The white pride underscore nn, it is the CLV underscore nn dot predict, it was the X test scale. The sorry, I need a little bit okay. The ACC underscore NN in here is the accuracy score, which is the Y test and Y part NN. And the last is CM underscore NN, it was the completion matrix using Y underscore test and Y part NN. For the accuracy, it has a good accuracy, but it was a little bit over 50, after fitting for the neural network and the last before like the support vector machine and the decision tree classifier, decision tree. But we need to talk about the neural network. And here we have the precision recall and F1 score. It has 100 for all of the 0, 1, and the accuracy, macro average, and weighted average. But the support is still same score as before. It was 1,638 and 362 with the support for the accuracy is 2000. And the printout like this, it was still same, but it has a different code in here. We using the neural network, not the SVM or decision tree before. Okay, maybe that's the classification. We're doing the clustering. For the clustering in here, I'm using the key-means clustering, which is the key-means is equal to key-means. N underscore cluster is equal to 2, random set is 42, and underscore init is 10. But the cluster underscore key-means, we're using key-means dot field predict, it was the X count in here. Then the cluster, oh no, and the seal underscore key-means which is the silhouette. It uses silhouette underscore score with X code and cluster underscore key-means. And for the last one is DBI underscore key-means, which is the Davis Baldwin underscore score. It using the X code and cluster key-means. For the printout, we have the key-means silhouette score. It was like this. Maybe I need to say it one by one. 0.8232 for 031 27581 and the Chemist Davis Baldwin index is 0.549672491752121. That was going a little bit long, sorry. Then we can doing some point out in here. We're using the pelleted figure with fixed size 606. We're using SNS scatter plot in here with the average rating as the X and the norm underscore ratings as the Y with two cluster key-means, and the pelleted title is given as clustering. The label is average rating in here. at the bottom, and the Y label is number of ratings, the vertical one. As you can see, the dot in here, the dot for blue is for the 0 and green for the 1. Then we move to agglomerative hierarchical clustering. Sorry. We're using agglo in here, Aglo equal agglomerative clustering. It was the n underscore clusters. We're using equal to the cluster underscore aglo equal aglo dot fit predict. We're using the x count in here. The cell underscore aglo is cell wide score. We using x count and cluster aglo with the dbi underscore aglo is divisible with score x count cluster and cluster aglo. And here we have the agglomerative cell wide score. I will be set one by one. 0.8703277868746809069. Sorry. For the augmentative device Bolden index, we have 0.395157471. Oh, sorry. 0611897. For the printout, we're using the SLS again, which is the scatter plot with the X is average rating, it was at the bottom, and the Y is number ratings, it was at the vertical one. For the color in here, for the 0, we have violet, and for the 1, we're using peach in here. We have the result of the data frame using model decision tree database SVM neural network key means and algorithm with the accuracy is SCC underscore DT, SCC underscore NB, SCC underscore SVM, SCC underscore NN, and for the key means and algorithm, the aglo is doesn't have any accuracy. For the silhouette score, we have at the key means and aglo with using seal underscore key means and seal underscore aglo. The face Bolden index is still same. We're using at the key means and the algo with dbi underscore key means and dbi underscore algo. For the evaluation in here, we have the accuracy silhouette score, the accuracy silhouette score, and the face Bolden index. For the decision tree, we have 100. That was a perfect score, but it will be have overfitting for the data. That's why we need to more accuracy with using knife base. At the knife base, we have the accuracy 8.889. Sorry, it was not perfect, but it was more fitting to the data. And the SVM, we got the perfect accuracy in here. It still have of overfitting, and the neural network is still saying it has overfitting that we need to make some accuracy, another accuracy for the classification. And at the key means we have the silhouette score. It already being circled. We have the key means we have silhouette score is 0.82324. It doesn't have any overfitting, but a little bit wrong. And the Davis Bolden index, we have 0.549672. For the agglomerative HC, we got silhouette score at 0.87032 and the Davis Bolden index we got 0.3955157. It was all of the data frame in here. I will be have the conclusion, but for sorry. For the data in here, as you can see, for the 100 accuracy, we scared that it was overfitting. But the nav base is a little bit lower than the accuracy, and it makes a perfect a perfect accuracy, not a perfect accuracy, but doesn't overfitting. That's why we doesn't need to make more classification. But for the decision tree, as we am a neural network, we need to be scared about the overfitting. Then for the silhouette score and the face bolding, which is the key method and the agglomerative HC in here, it has a good score, but it still have a little bit lower score at the index at the face bolding. For this, we know that all of the data, no, all of the classification and clustering have a minus and plus for each other. For the more accuracy, we can use decision tree as we am a neural network, but you still need to be aware about the overfitting. But for the clustering, we can use the agglomerative HG. It was more at the silhouette score, but minus at the devious bolding. But for the perfect one is using the key means. It was a more good of the score with the silhouette score and the devious bolding index. It doesn't really low, but doesn't really high. Maybe just that I can explain to you guys. I'm so sorry because I'm bad in English. I'm so sorry if I doesn't can to represent I can explain all of the conclusion in here, but I hope you guys can understand what I want to sharing in here and want to talk about. Maybe just that. Thank you for watching and see you guys in the next video. Bye bye.